Hello again. Welcome back to Pre-Algebra with Miss Betsy. We're continuing our work where we are talking about how to perform operations involving integers. We are in section 4.4, which is solving integer equations using addition and subtraction. I'm using as my text Pre-Algebra for Christian Schools by Bob Jones University Press. Don't have to use that. Solving equations involving integers, you do it the same no matter what your textbook is. So welcome along for the ride. Before we get started, my infamous famed joke for today is, who stole the soap out of the bathtub? The robber ducky did. So we remember that when we are solving equations to find the variable, when we initially begin, we have an equation that's in balance. What you have on the left-hand side of the equation is the same as what you have on the right-hand side of the equation. And as long as you perform the same operation to both sides of the equation, it still remains in balance even though it looks differently. It's like that seesaw that we have. That you've got two kids who have the perfectly balanced seesaw. Add 20 pounds to one side, seesaw's not level anymore. What do? You add 20 pounds to the other side, and the seesaw comes back into level. So with arithmetic and algebraic operations, as long as you do the same thing to both sides on both sides of the equal sign, your equation is still in the same relationship to one another, and it's still balanced, it's still equal. It's that principle that we use where we have inverse operations, operations that undo one another. If I start right here with nothing in my hand and I do plus one marker, I now have one marker in my hand. I do minus one marker, and I'm right back where I started. I had nothing to begin with in my hand. I had nothing at the end. Addition and subtraction are inverse operations. So this is what we're going to use with integers. I'm going to use the principle of when we have isolating the variable. Let's say that we have x plus 23 is equal to 17. When you are solving equations to find the value of an unknown, what you're doing is you want to do what they call isolate the variable. That's where you get whatever your variable is all by itself on one side of the equal sign. And then how are we going to do this? We're going to use inverse operations. We're going to say, okay, I started with an x. What did I do? I added 23. What's the inverse operation to addition? Well, addition and subtraction are inverses. So if I started with an x, I want to get back to where I only have an x. I add 23. If I apply the inverse, I subtract 23. X plus 23 minus 23. Then I'm going to get back to x all by itself. X plus 23 minus 23 is equal to 17. Now, is that all that I have to do? No. We started off with an equation that was balanced. We said that x plus 23 on one side had the same value as 17 on the other side. You see, so it was balanced. But then we subtracted 23 from one side of the equation, and the equation's out of balance. Your seesaw's not level anymore. So what we have to do is make sure that we do the identical, perform the identical operation on the opposite side of the equal sign. So we've subtracted 23 from both sides of the equation. X plus 23 minus 23 times just x, or x plus 0 first if you want to show that positive 23 minus 23, that their sum is a 0. You could say x plus 0 in here. The next step would say that x is equal to 17 minus 23. If you're at when you get to the point where you can look at this and say, okay, I know 17 minus 23 is a negative 6, go ahead and do that. But while you're learning how to deal with signed numbers and with numbers that are negative, remember that subtraction is the same as adding the opposite of a number. What have we done here? We've subtracted a 23. What's the opposite of 23? The opposite of 23 is a negative 23. So subtraction is the same as adding the opposite of a number. Goes back to section 4.2, adding integers. How do you add signed numbers? You have positives and negatives. You subtract their absolute values, which means just treat them like they're positive numbers. 23 minus 17, off to the side, you have your scratch. If you want to show 23 minus 17 as a visual, to help you remember that 23 minus 17 is 6, we have that x is equal to 6, but we're not finished because we're dealing with signed numbers. We have positives and negatives here. So you have to look at these two numbers and see which is the larger absolute value. The negative 23, the absolute value for that is positive 23, which is larger than the 17. So we're going to use the sign that goes along with the negative 23. So we have a value for x of negative 6. Now your problem tells you go ahead and check this. Well, how do you check a problem? Same way you've been checking any other problem. You substitute the value back in for the variable in the original problem. So we're going to do check x has a value of negative 6, so we're going to say negative 6 plus 23, is that equal to 17? Or does this sum equal 17? Well, right here we're adding signed numbers again. We have a negative 6, we have a positive 23. You subtract the numbers. What a lot of our minds say is that's just 23 minus 6. We don't really address the issue that technically we're taking absolute values. Say 23 minus 6 is 17. Is it going to be a positive 17 or a negative 17? Because we got a negative 6 and a positive 6. How do we know what sign we're going to use? We use the sign that's in front of the larger absolute value number, which is a positive. So we have that 17 is equal to 17, and you have done your own check, verifying and validating the fact that negative 6 is in fact the solution to x plus 23 is equal to 17. That's all you do. You go through another problem or two for you. What if we would have y minus a negative 7 is equal to a negative 18? We have that in the board. So we're subtracting a negative 7, okay? So let's see what we want to do. What have we done? What's the inverse operation of subtraction? It's addition. So we've got a couple different things going on. We're not dealing with adding and subtracting negative numbers right now. All that we're dealing with is isolating the variable. And the way that we're going to isolate the variable is we look and see what's happened. What have we done to the y? We've subtracted. What have we subtracted? We've subtracted a negative 7. To use the inverse operation, you subtract one thing, you add the identical amount. So you have y minus a negative 7. Since we've subtracted, the inverse operation is addition. We've subtracted what? A negative 7. We're going to add what? We're going to add a negative 7 to both sides of the equation. Everybody see what we're doing? We've subtracted what? We've taken away a negative 7. So you have to add back exactly what you've taken away. And this is where it gets a little bit strange seeming to you when you're beginning to work with signed numbers for the first time. You sometimes get a little bit confused with all of these extra negative signs. But all we're doing is subtracting a negative number. We want to add that same negative number to both sides of the equation. When you add and subtract the same number, you always end up with 0. Sorry, I can't edit that out. And you have y plus 0, or y, is equal to negative 18 plus a negative 7. We're adding signed numbers. The signs are the same, so it's 18 plus 7 is 25. Since the sign is negative, y is equal to a negative 28. And yes, I know I actually could edit out those sneezes. Way too much time involved for putting these together, so I'm sorry you get to hear me sneeze. Y is equal to negative 25. What's the next thing that it says to do in the problem? Well, the problem tells you to go ahead and check. I've lost the cap to this. And I understand that it's October, but we'll just use Christmas colors now. So what are we going to do? We're going to substitute in a negative 25 for our value of y. So you want to indicate that you're checking. When your instructions say in your textbook check, they want you to actually write check and then do all of the work. By taking the value that you arrived at, negative 25 minus a negative 7, is that equal to a negative 18? We're going to change subtraction into an addition problem. Subtraction is the same as adding the opposite of the number. Does that equal negative 18? Negative 25 plus 7. We're adding numbers that have different signs. You subtract the smaller from the larger. 25 minus 7 is 18. How do I know if it's going to be a positive or a negative? I look for the sign that's in front of the number that has the greater absolute value, which of course is 25. So we have a negative 18 does indeed equal a negative 18, and we have just verified that our solution, y is equal to a negative 25, is the correct answer to this problem. See, very, very straightforward. So use the opposites property of addition to solve equations involving integers. Okay. This may be a way of thinking of it that will be just a little bit different for you. We talked about the opposites property of addition a few videos ago, and we said that if you take a number and add its opposite, you always end up with 0. So let's say that we have z plus a negative 32 is equal to a negative 19. So if we want to just add, this says z plus a negative 32. What's the opposite of a negative 32? It's a positive 32. So you have z plus negative 32 plus, let me use my different color. We're going to add a positive 32 to the left-hand side of the equation. Because we have added a positive 32 to the left-hand side of the equation, you have to add a positive 32 to the right-hand side of the equation to keep that equation in balance. We have here, we're adding together a number and its opposite. Negative 32 plus 32 is always equal to 0. So you have z plus 0, which you don't have to write. Z is equal to negative 19 plus 32. Side numbers again, different signs. Subtract the smaller number from the larger number. It's 13. And you keep the sign of the larger number. Is this actually the correct answer? Well, I want you to check it. So the second part of your problem is check. And you say, what happens if I put a 13 in for my z? I'm going to substitute in 13 for z plus a negative 32. Is that equal to a negative 19? All we've done is we've substituted the 13, which is the value that we came up with for z. We substituted that into our original equation. Now we're going to check and see if we get the right answer. Different signs, you subtract 13 from 32 on your scratch work. 32 minus 13 is 19. Is it going to be a positive or a negative 19? Well, the negative 19, the negative sign is in front of the 32, which has the larger absolute value. So you have to take that sign, and you see that negative 19 is in fact equal to negative 19. And this is what's involved in solving equations using integers, where you're adding, where you're using addition or subtraction. So go ahead and play around with these. If you get stuck, shoot me a text, and I'll see you next time.